Right, grade 8. So today we're going to be looking at mechanical advantage, and namely how to calculate mechanical advantage through levers. All right, this same formula that I give you today will apply to lever systems, gear systems, pulley systems, etc. So it is quite useful to remember the formulas that I'm going to be teaching you today. All right, so when we do the calculation, we always have to remember that mechanical advantage, which is abbreviated as MA, is equals to load divided by force, right, or effort. So it says load and force can be measured in newtons or kilograms. All right, we are going to make use of newtons to do the calculation. So it's always important to remember that you do your calculations in newtons. You don't want to have one in newtons and one in kilograms. Okay, so you never want to have this happen. You always want to convert to newtons. How we do this is we always have to remember that 1 kilogram is equals to 10 newtons. All right, so if you're ever given something in kilograms, please times it by 10. All right, and then you'd have your answer for how many newtons you're needing to use. Okay, so for example, if we wanted to work out the mechanical advantage of a load of, say, 10 kilograms in this case, over 100 newtons, we'd say 10 kilograms times by 10 newtons would equals to a mechanical advantage of 100 newtons divided by 100 newtons of effort to pick this load up, and that will give us a mechanical advantage of 1. Okay, so in this case we can see now that this is not necessarily giving us a mechanical advantage. We'd have to put the same amount of effort in order to lift up a load of 100 newtons. Now if you didn't convert to newtons and you left it in kilograms, you would have an obscured answer and it wouldn't be correct. So please remember, if you're ever given anything in kilograms, to first convert to newtons. You'll see in your textbook all the questions are already in newtons for you, so there's no conversion to take place. But just for in case you get it in an exam where you're given 1 in kilograms and 1 in newtons, please make sure that you always convert the kilograms to newtons before continuing with the formula. All right, so please do not confuse yourself with this, but just to go over it again, mechanical advantage will always be equals to load over force, and an easy way to remember this is by drawing yourself a triangle. All right, and inside the triangle you'll have mechanical advantage, you'll have load and force. So how the triangle works is mechanical advantage is equals to load divided by force. So if it's above one another, it's divide, so this would be divided by force. If you want to work out force, it would be force is equals to load divided by mechanical advantage. All right, and if you wanted to work out the load, then you'd say mechanical advantage times by the force would equals to the load. And you can keep on using this triangle to go back to and make sure that you've done the work correctly and just double check your answers. So we'll just go through one more example, and I'll use the example in the textbook that they've given you. So if you look on page number 80 in your textbook, they've given you a lever system, right? And they've said to you that you have a load of 45 newtons. Right, and you have a force of 45 newtons. Okay, and in this case, the load arm and the effort arm are exactly the same distance, so we know that there's no advantage given to us there. We are working out now what is required to lift up a load of 45 newtons. So we go back to our triangle and we say, okay, we want to work out the mechanical advantage of this system. So because we have the load already and we have the force already, so again, as we did here in this example, we have to say mechanical advantage is equals to load over force, and then we'll say that mechanical advantage is equals to 45 newtons. Please remember always to put in the unit over 45 newtons, and again that will give us a mechanical advantage of 1. Okay, so again, we have all these numbers, and then if we had to work it out vice versa, so if we had to say we want to work out the force of this system, let's say we never had the force, okay, but we did know that it was a mechanical advantage of 1, again, we'd have to say that force is equals to, and then we know that it would be load divided by mechanical advantage. We know that the load is 45 newtons over 1, because we know that our mechanical advantage was 1 by doing the calculation. Right, and therefore we can say that our force is equals to 45 newtons. All right, so always use the triangle as a guideline. The triangle will always help you with the formula. Key points to remember is always, if you're given kilograms, to convert to newtons. Right, you don't want to leave it in the kilogram form, and then you always have to follow the same principle of mechanical advantage equals to load over force. right? Force equals to load over mechanical advantage, and load is equals to mechanical advantage times by force. Right, this is pretty simple and straightforward. So you're going to go complete activity 1 on page number 80 and 81. There's 6 questions in total there for you. As I said, there's no conversions from kilograms to newtons, as all of them have been given to you in newtons already, right? And then next week, when we move on to working out the load distance and the effort distance, there's a slight change, all right? But then I don't want you to confuse yourself. Make sure that you remember this perfectly first. And if you have any questions, please ask me. After we've done this thoroughly and we know how to do this properly, then we'll move on to working out mechanical advantage through load arm and effort arms.